Okay, so today's topic is structure of atoms. Structure of atoms. So atoms भनेको atoms are basically the building blocks of every matter, right? So every matter doesn't matter what state it is, right? The matter can be of liquid state, can be of solid state, can be of gaseous state, can be a plasma, right? Can be a plasma as well. Every of the state, each and every state has atoms, right? Everything is made up of atoms, and atoms are basically the smallest entity that can take part in a reaction, right? So there are smaller particles than atoms, right? So there is an atom. Let's say there is an atom. This is the nucleus of an atom, and there are electrons revolving around the nucleus. So saying that atoms are the smallest or indivisible elements or indivisible quantities that are present in the universe, that would be wrong. But stating
Yeah.
atoms, yes, bhai.
Screen share भएको छैन तपाईँको
Screen share भएको छैन? Okay, 1 second ल. अब share भयो? Okay. So आज गर्नुपर्ने, we'll study structure of atoms. Atoms भनेको के हो? Every one of us know what is an atom. We should be knowing by now. So I'm the standard someone, we should be knowing that. Atoms भनेको these are the building blocks of all matter. So every matter is made up of atoms, right? And atoms, like how atoms were perceived before, like proper explanation of atoms, like the extent of knowledge that we have right now about atoms was not the same like 200 years ago or maybe 250 years ago, right? So 250 years ago, atoms were believed to be indivisible, right? They were indivisible, and these were the smallest entity, right? Nothing can be smaller than an atom, and they were indivisible. Matlab they could not be divided into smaller parts, right? But later, further studies in atoms, further discoveries of electrons, neutrons, and protons brought us to a conclusion that atoms are not the smallest entities, right? But they are still the smallest entity that take part in a reaction. So atom भन्दा सानो केही हुँदैन that can take part in a reaction, right? The electrons alone don't take part in a reaction. So atoms as a whole take part in a reaction, right? So if I say sodium plus chlorine gives sodium chloride, so I'm not considering just one one electron that sodium gives to chlorine in this reaction, right? So I'm talking about entire sodium atom taking part in a reaction with the entire chlorine atom. So before the idea about atom was like comprehensive and like well known like what we have right now, it was believed that atoms were totally indivisible. You could not divide atoms, right? Atoms are the smallest entity that can be ever present, and they were not divided. They could not be divided. But later studies, various experiments, the cathode ray experiments, experiments, there were a lot of experiments carried out, and those experiments proved that atoms are not only indivisible, but they are also not the smallest entities, right? There are more smaller entities like electrons that revolve around the nucleus of an atom, right? So nucleus ma ke huncha, we have proton and neutron in the nucleus, and electrons just revolve around them, right? And the way they revolve is also ambiguous, pura achammako huncha, like because electrons do not follow a single orbit, right? They are found in clouds. So the way you represent electrons in your level right now is, let's say this is a nucleus for an atom, right? So the way you represent electrons should be dotted lines, which would basically represent a cloud of possibilities, right? Electrons can revolve anywhere around this, right? You can't specifically say you'll be revolving at this plane, at this speed and this velocity at this position. You can't say that. So electrons can be found anywhere in a range of like cloud bhन्छ त्यसलाई. So electron cloud bhन्छ. So basically you can find yes, cloud, CLOUD, cloud. So electrons can be found anywhere here. You can't just specify that electrons are here specifically. No, you can't say that. There'll be a range of possibilities for the position of electrons where they revolve around the atom, like I mean the nucleus, right? So these are the things that will come into this chapter later on, right? So we'll start from the basic itself. So I think this is like done in class 10, maybe 10th and 11th, but I'll revise it once again. So there were atomic models, okay? There were scientists who were like keen in discovering about atoms. So they wanted to discover more about atoms, and they wanted to discover more about what's inside an atom, right? They were far-sighted scientists who not only like followed the ideas of other scientists, the well-known concepts about atom being indivisible. They rather took their own like studies to discover what is inside an atom, and this led to discoveries one after the other, and finally we have the theory that we have right now, right? And it's one of the most comprehensive and one of the most informative details about an atom. So first one that is recorded, like one of the important discoveries was done by Thompson. Okay, Thompson was the one. Thompson's model was the Thompson model of an atom, or we also call it as plum pudding model, PLUM plum, PUDDING pudding model. So this was the first model that gained recognition about the structure of an atom. So how an atom looked like, how an atom behaves, right? So according to this guy, so basically you can understand it as this model as a watermelon. You can just think about a watermelon, right? So you have a watermelon, and there are negative charges scattered around it like this, like the beads of the watermelon. Watermelon ko seeds dosto. These seeds are basically the negative charges, right? And the red colored thing inside the watermelon is the scattered positive charge. Positive charge. So no positive entity was defined. Okay, we did not come to a conclusion at that moment that we had positive particles called protons, right? It was just said that positive particles were not particles. Positive charge was spread around, right? Like the red part, the edible part of the watermelon, right? And negative charges were scattered around like the seeds of the watermelon, right? So this was the first kind of atomic model that developed, right? And this was basically after the development of electrons, right? So electrons were developed, electrons were discovered, in fact, by that time, and due to which they had Thomson had an actual model of an electron inside. So he actually considered electrons to be the seeds of this thing, right? So his model basically consisted of something like this, right? The inside the red part is the positive charge that is spread around, and this the seeds are the negative electrons. So this was the Thomson's plum pudding model. So this is wrong in so many aspects, right? Right now, if we compare with what we know, even before teaching all entire chapter completely, so you basically know that there is a nucleus in the center and there are electrons revolving around, right? So this is the thing that we know right now, and this is the thing that Thomson formulated. Like, when was it? It was around, I think, 1700s. I'm not sure about the date. So this, just look at the contrast, how different these two are, how different the way we assume, the way we conclude what atoms look right now, and what Thomson produced in that time. So see the contrast, how different they are, right? It's completely different and completely wrong, right, if you think about it right now. But this was actually a stepping stone for development of atomic theories, right? Atomic theory, atom कसरी बन्ने, atom भित्र के हुन्छ. So the tough questions about what is an atom made up of, what is inside an atom, and why is atom indivisible, in that era of time. Till time, these questions were the hot topics, right? Hot questions. And this theory actually made it possible for the process of atomic study to go forward, right? This was a stepping stone in atomic theory. So this was Thomson's model, not that intricate, not very difficult. It's like a watermelon. The red part is the positive charge that is spread around evenly, and this seeds are the negative electrons that are found like at some position inside the atom. So it's random, right? So this is the first model. So is there any doubt regarding this model? Any doubt? No doubt, right? So there's yes, bhai. Come on. Yes.
And the Thompson watermelon complete
because the scope was so different. त्यति बेला scope different थियो नि. There was like so different, so rare scope क्या हो. Oh, you could assume like you see a watermelon, right? And that moment of time you see a watermelon and you see negative particles.
And यस्तो पनि त्यो पनि हो. अब मैले भने अझै भन्नु पर्दाखेरि चाहिँ किन अब एकछिन
Go on.
अनि यो मोडलमा चाहिँ कसरी कन्क्लुड आयो जस्तै अब मैले त्यो अल्फा पार्टिकल अब बीचमा
No, he didn't conclude. There was no experimental studies. Okay, so त्यति बेला चाहिँ के हुन्छ भने hypothesizing was like hypothesis was played an important role, right? It has been playing an important role till now. So when you hypothesize something, hypothesis is the first stage of formulation, right? So before anyone saw a black hole, Einstein was the first one to hypothesize a black hole, right? He came up to a calculation stating that there are points in the universe where gravitational pull is extremely high, right? But he never said there was a black hole or something there. He just said there are regions where gravity is extremely localized, right? Gravity is located in a like very small area, and gravity is extremely high in that area. So his study of general relativity came to a conclusion that there are some locations of extreme gravitational pull in the universe, right? There are various places in the universe this happens. Now Stephen Hawking carried out this thing, right? Stephen Hawking carried out this thing and later came up to a straightforward conclusion that there are things called black hole in the universe. So once Einstein hypothesized it, no one had a clear picture of a black hole. No one even thought there would be a black hole, right? If a person in the 1920s were told about that there is a place in the universe where gravity is so high that even light won't pass through, so they would laugh at you, right? They would actually laugh at you, because like no one ever thought about that. No one ever thought that would be a possibility. But the thing was, hypothesis it paved the way for everything. So Einstein's calculation brought about a hypothesis, brought about a conclusion that something is there in the universe where gravitational pull is maximum, where gravitational pull is so large, so big, like so the pull is so strong that even light doesn't pass through it, right? So त्यो चिजलाई चाहिँ स्टिफन हकिङले क्यारी फरवर्ड गरेर ही केम अप टु अ स्ट्रेट फरवर्ड थ्योरी, एउटा कङ्क्रिट थ्योरी आयो कि देयर आर ब्ल्याक होल्स, राइट? एन्ड इन 2016 there was like actually photos of black hole being clicked, right? First photos of black holes. So त्यस्तो हो. So basis of every discovery is hypothesis. So when you hypothesize something that may become a theory, it's not necessary that every hypothesis will go on to become a theory, right? Is a hypothesis like there are many hypotheses that are still hypotheses, right? They have never turned into a theory, known theory, right? Space time travel has been a hypothesis since so long, right? साइन्स फिक्सनको कतिवटा के हुन्छ मुभिज नोभल्स आर बेस्ड अन टाइम ट्राभल, राइट? दिज आर नाउ वी टर्म इट एज फिक्सन राइट नाउ. हु नोज आफ्टर 20 years टाइम ट्राभल is found to be a possibility. Now then they will not term it to be a fiction, right? So fiction term hurts on the time travel, but now it will automatically become a theory, it will automatically be a hypothesis, it will automatically be a possibility, right? So basis of every discovery is imagination and hypothesis. So if you can imagine things, you can be like this guy Thompson. He just imagined that atoms may look something like this, in like a watermelon with the seeds all around, the electrons spread around like that, right? So he hypothesized it this way, and he found out that there may be possibility that atoms can look like this. So is your question answered? Okay. So this is how the Thompson's model came into existence. This was not as accurate as the thing that we know right now, right? It's not that accurate. But the second model was the Rutherford's model, which actually came a bit closer to what we know right now, right? So Rutherford's atomic model, or we also call it as Rutherford's nuclear atomic model. So why this nuclear thing pops up? This is because Rutherford was the first one to hypothesize a nucleus. Not hypothesize, he actually did an experiment and proved there is a nucleus, right? But the definition of nucleus in those times were different, and the definition of nucleus right now is a little more refined than what it was then. But still, he was the one who found out the presence of nucleus in an atom. So how did he do that? So there was a famous gold foil experiment that Rutherford carried out, okay? So what happened was, in this experiment, what he did was, he placed a thin gold foil, right? Thin gold foil, and he had an alpha emitter here. So there is an alpha emitter. So alpha emitter is basically a doubly charged helium atom, so He2 plus. So this is an alpha particle, right? So this is an alpha particle. It is just the proton. You don't have an electron in an alpha particle, okay? So we know helium has the tendency, helium can be made to lose electrons. So if it loses 2 electrons, it becomes He2 plus. So this thing doesn't have an electron now. It just has the protons inside, right? Protons and neutrons inside the nucleus. So basically, this doubly charged helium atom or alpha particles are positive particles. So is this clear? What is doubly charged helium or doubly ionized helium and alpha particle? So alpha particle is basically a helium atom which has lost 2 electrons. So doubly ionized. So you have ionized helium twice. So one electron is removed, second electron is removed. Now helium doesn't have any electron inside it. It just has protons and neutrons in the nucleus. So it is basically positive, right? So what it did was he placed gold foil here, right, and he put some reflecting mirrors behind, right, reflecting mirrors or fluorescent screens actually fluorescent screen all over the apparatus. So he placed fluorescent screens all over the apparatus, and he like allowed a beam of alpha particles to hit the gold foil, right, and he tried to make some observations out of it, right. So he observed that most of the alpha particle passed through undeflected. So most of the alpha particle just went through the gold foil, right? It just went past the gold foil, right? A small portion of the alpha particle rebounded at certain angles. So it didn't go straight in. It rebounded at certain angles. So it rebounded at different angles. It like went in different angles, right? And even a smaller portion of alpha particles completely rebounded back. Okay, so these three were the observations of Rutherford's experiment. So he placed a gold foil. He allowed a beam of alpha particle to fall on the gold foil. He had fluorescent screens or polarizing mirrors, whatever it's called, to detect where the alpha particles are going, right? And he found that most of the alpha particles just went through the gold foil undeflected. So they did not deflect with striking the gold foil. Okay, they just went in straight, right? So most of them went straight. So let's say 95% went straight. Now a small portion that is left, now 5% is left, right? So a small portion of this 5% went at some angles, so deflected at certain angles. So this was the angle of deflection in which the alpha particle deflected, right? Deflected at certain angles. And even a smaller portion of what is remaining came back completely deflected. So they just went in, completely deflected, and came back. So this was very small portion of it, right? So this was the observation. So it should be very clear. So most of them went straight, some deflected at some certain angle, and some even smaller portion completely rebounded back. Okay, so this was the observation that Rutherford made in his experiment, right? Now what is the inference that he brought about? So inferences is very important. Why? What is the conclusion that he brought out from his experiment? So what was the first observation? The first observation was most of the alpha particles passed through the gold foil undeflected, which basically meant that atoms are mostly empty, right? So gold atoms are, yeah. So he didn't know there is a nucleus by then. Okay, so he just was discovering through, and there are electrons revolving around the nucleus, right? And alpha particles are coming and they are going in straight because there is nothing to obstruct their flow, because atoms is mostly empty, right? So there are like electrons revolving around at certain locations, and certain locations where electrons revolve करते हैं, but these locations are very minimal. You can't predict the electron anywhere in the nucleus. It can be anywhere, right? It can be anywhere around a cloud. So most of the alpha particles passed through undeflected, which basically meant that most of the atom is entirely empty, right? It is empty. There's nothing inside an atom. Most of the space occupied by an atom is empty. So most of the space that an atom occupies is empty. So that was the first inference that they drew from the first observation. So first observation was most of the alpha particles went undeflected, which meant atoms are empty. Most part of the atom is empty. So now second observation, what it did was some deflected at certain angles. So some deflected at certain angles matlab some alpha particle went into the atom, right? So alpha particles are beaming inside the atoms, and some deflected at certain angles. So this is the nucleus. These are the electrons revolving around. Now some alpha particle deviated at some angle matlab they just came in proximity of the nucleus. So nucleus is positive, alpha particle is also positive. So due to which electrostatic force of repulsion will start acting on them. So because of which the alpha particle is deflected by some angle, right? So second observation के थियो, some of the alpha particle deflected by a certain angle, right? By certain angle. So another alpha beam is coming from here. Due to its proximity with the nucleus, it's deviating at a certain angle. theta 1, this is theta 2, right? So this was the second inference, so which meant that there is something in the atom that is repelling the positive charges to some angle, to some by some angles, right? So second inference was there is something inside the atom that is making the positive charge go away, right? And the third inference, so what was the third observation? The third observation was some of the alpha particles completely rebounded back, which meant some of the alpha particles going straight into the nucleus due to the extremely high electrostatic force of repulsion here came totally rebounded back, right? Which meant that there is a centralized positive charge in the atom. म लागु हुँदैछु आदित्य हो कोही बेला okay, so is the first inference clear?
Yes.
Atoms is mostly empty. Is the second inference clear? Some of the alpha particles deflected because they came in close proximity with the nucleus, right? Now third one चाहिँ के हुँदैछ भने there are very few alpha particles that just went straight into the nucleus, right? And so if I give you an example, okay, gold is a very heavy nucleus, okay, gold ko atomic number is more than 50, so there are more than 50 protons in the nucleus, right? And there is alpha particle or helium which has 2 protons in the nucleus, right? So now if I give you an analogy, if a car is coming here, a car, 4-seater car, and an 18-wheeler truck is coming from this direction, right? And they collide, head-on collision. So which one will be thrown further? Will the car be thrown further or the truck? Come on.
Car.
Yes, obviously the car will be thrown further. The truck will not move, right? The truck will not move at all because it's very heavy. Rather, the car will be pushed away further. So the same thing is happening. Now the nucleus of gold is a truck because it has so many protons, more than 50 protons, right? And there is helium or alpha particle that has just 2 protons. So these two are coming in a head-on collision process. So because of which the protons are completely pushed back, right? And nothing happens to the nucleus. The nucleus doesn't move at all, right? So the third inference is, since some of the alpha particles returned back completely rebounded, which meant that there is a centralized positive charge. There is a positive charge in the center of the atom that causes this positively charged helium atom to fall back, right? Which meant there is some concentration of mass and charge in the center of an atom, and that was known as nucleus, right? There is a concentration of mass and positive charge at the center, right? There is something that is heavy and something that is positive in the center of an atom, which is actually causing the positive alpha particles to completely rebound back, right? And that concentration of mass and charge was termed to be the nucleus. That is why we have the nuclear model of an atom for Rudophor. Rudophor nuclear model of an atom. So is this clear? What are the 3 observations and what are the 3 inferences?
Yes.
Clear, Sritesh? Is it clear?
Yes, sir.
Okay, so Rutherford, through his experiments, came to a conclusion that there is something that is heavy and something that is positive in the center of the atom, right? And that positive thing is causing the alpha particle to completely rebound back, right? And that positive charge, that positive mass is said to be the nucleus of an atom, right? Yes. So because of that, we get to a conclusion that the model of an atom suggested by Rutherford was the nuclear model of an atom. Rutherford's nuclear model of an atom, right? So according to that model, so it is very simple. Don't write it, okay? Just try to understand. It's very simple. So according to that model, most of the charge, so first statement of the model is most of the charge, most of the positive charge and most of the mass of the atom is concentrated on the center of the atom. So first postulate Theo, Rutherford's nuclear model of an atom is most of the positive charge and most of the mass of an atom is concentrated at the nucleus, at the center of an atom, right? Second postulate of Rutherford's nuclear model of an atom is most of the atom is empty space. Most of the atom is nothing but empty space, right? And third postulate of Rutherford's model of an atom is Electrons revolve around the nucleus in circular orbits. So this was the 3 postulates of Rutherford's nuclear model of an atom. This third postulate is not so important. You don't need to consider about this. Just remember the 2 postulates. First one is the most of the mass of an atom is concentrated in the center of the atom, and that place is known as the nucleus of an atom. And second one is most of the atom is empty. Most of the space occupied by an atom is empty. So there is nothing inside the atom mostly. So 95% of atom is mostly empty space, right? So that should be clear. So is this Rutherford's nuclear model of an atom clear? So you should know the observation. They might ask you the experiment, okay? So if they ask you the experiment, it will be very, very interesting to write it. So you have to draw the schematic. So you don't need to be perfect with your drawing, okay? You don't need to be an artist. So you just need to draw the required things: a gold foil, alpha beam that's coming, and most of the alpha particle passing straight, some bending at a particular angle, right? And some completely rebounding back, right? And after that, you need to write the observation. What did Rutherford observe in his experiments? So what all did he observe? He observed 3 cases. First being the alpha particle passing undeviated. Second being the alpha particles deflected at a very small angle, and the third observation being that some of the alpha particles being completely rebounded back. And what are the inferences he brought out from the observation? So after he observed something, he came to a conclusion that the charge and mass, the positive charge and mass of atom is centralized, and it's known as nucleus, right? And second conclusion is when the alpha particles come closer to the nucleus, they bend at a particular angle due to the force of repulsion between the positive nucleus and positive alpha particle. And some that come head-on collision, सीधे out as a nucleus, but they are coming straight into the nucleus, they are completely rebounded back because of the same property, because of electrostatic forces of repulsion, right? And he finally came to a conclusion about the Rutherford's nuclear model of an atom. So nucleus is present, it is centralized, it has most of the mass of the atom. So that is the postulate. It is nucleus is present, right? It is positive in charge, and most of the mass is present in the nucleus. And second postulate is most of the space that an atom occupies is empty. So that is the Rutherford's nuclear model of an atom. So I think that is clear. Or do I need to explain it again? No, right? Okay, so this is Rutherford's nuclear model of an atom. I'll not like teach more than this for today. This should be enough for first day.
There are questions.